Mathematically speaking, if you want the absolute highest probability of marrying the best possible person, you must ruthlessly reject the first 37% of people you date.
Which sounds incredibly harsh when you just say it out loud like that.
It really does. But today, our mission in this deep dive is to map the mathematics of optimal stopping and statistical sample sizes onto one of human biology's most chaotic processes, finding a life partner.
Right. It's a brilliant collision of disciplines. We're taking a strictly technical approach to a highly emotional problem here.
Exactly. And you, listening right now, have probably felt the tension of this data problem in your own life.
Hmm.
We're analyzing a fascinating source text that brings rigid probability into the dating world.
Yeah, analyzing precisely when a person should stop searching, stop gathering data, and finally commit.
Because it's not a discussion about romantic destiny, is it?
No, not at all. We are looking at this entirely through the lens of decision theory, specifically how to optimize your choices when you're operating in a state of imperfect information.
Okay, let's unpack this. Because the core dilemma the text outlines is a massive vulnerability in human logic.
It really is.
I mean, if you've dated, say, 5, 10, or 15 people, how do you mathematically justify deciding that the very next person is the one?
Right. Without a statistical framework, how do you stop yourself from holding out for an unknown, statistically superior option?
Someone who might be waiting just one more swipe or, one more date away.
You don't. And that is exactly why people get trapped in these endless optimization loops. That's where the secretary problem comes in.
The secretary problem.
Yeah, it's a classic exercise in probability theory. The premise is basically this. Imagine you have to hire a secretary. You have a known fixed number of applicants.
Okay.
And they are presented to you in a completely random order. You can rank them relatively against each other as you interview them.
But there's a catch, right?
A huge mathematical constraint, actually. You cannot go back to an applicant you have already rejected. Once you pass on them, they are gone from the data set forever.
Wow. So it's the ultimate strict liability algorithm. You either commit immediately or you completely lose the data point.
Correct. And under those strict parameters, mathematicians wanted to know, what is the algorithm that maximizes your probability of selecting the absolute best candidate in the entire pool?
And the proven answer is the 37% rule.
Exactly. Mathematically, you must spend exactly the first 37% of your search purely observing. You make absolutely no commitments.
You just gather data.
Right. You simply gather data to establish a baseline. You identify the highest benchmark of quality from that initial group. Then, the moment you pass that 37% threshold, you change your operational mode.
You flip the switch?
You do. You immediately commit to the very first candidate who exceeds the highest benchmark you set during the observation phase.
But the text mentions that 37% isn't just like an arbitrary chunk of time, though. It's a specific mathematical peak.
Yeah, it has to do with the calculus of balancing two competing risk curves. That is the engine under the hood of this rule.
Because you have the information curve and the opportunity curve?
Right. On a graph, as your observation time increases, the amount of information you have goes up. That's a positive curve. You know what a good candidate actually looks like.
But simultaneously, the number of remaining available candidates goes down.
Exactly. That's a negative curve. So the exact point where those two probability curves intersect, where you have gathered the maximum amount of information while retaining the maximum amount of opportunity, is derived from the mathematical constant E.
The equation yields 1 over E.
Yes, which translates to 0.368, or roughly 37%.
I have to push back on this, though, because the rigidity of this model feels fundamentally incompatible with the reality of human behavior.
Oh, so?
Well, if I'm programming an algorithm to sort through server hardware or hire a literal secretary, fine. But human beings aren't immutable data points on a spreadsheet.
That's true.
In reality, you sometimes can go back to an ex-partner. And more importantly, unlike an applicant in a simulation, a romantic candidate has agency. They have to choose you back.
Right. The algorithm is running in both directions simultaneously. And the mathematics of the pure secretary problem assume unilateral choice, which, as you point out, is a failure when mapped directly onto human relationships.
So does the source material address that?
It does. It doesn't ignore this at all.
Right.
It defends the mathematical purity of the 37% rule as a baseline, but it absolutely concedes its real-world application is different.
Right. You do not literally date 100 people, reject exactly 37 of them, and marry number 38.
Exactly. Its true utility is as a conceptual framework. It proves mathematically that an initial non-committal observation phase is not a waste of time. It is a statistical requirement.
So it's about solving the behavioral extremes.
Yes. It provides a logical framework to rescue people from two specific failures of decision-making. The first is premature commitment.
Settling on a data point before you've established a statistically significant baseline.
Right, before you even know what a good match actually looks like. And the second failure is the paralysis of endless searching,
The mathematical fallacy that a larger data set will automatically yield a better maximum value.
which isn't always true once you pass that optimal stopping threshold.
That reframing is incredibly useful. If the math dictates that an initial observation phase is a structural requirement to build our baseline, the immediate operational question becomes pretty obvious.
How much data do we actually need?
Exactly. In human terms, how many distinct relationships do you need to experience to have statistical confidence in your own benchmarks?
The source breaks this down by examining sample sizes. It specifically contrasts the data yield of dating 5 people versus dating 10 people.
And the difference in the utility of that data is massive.
It really is.
The text notes that at an N of 5 dating 5 distinct individuals, you are only generating basic comparative metrics.
Right, you're learning the physiological and immediate psychological responses your body has to different stimuli.
You learn if a highly extroverted personality makes you feel energized or if it just spikes your cortisol.
Yes. You figure out the raw difference between a conversation that naturally flows and one that requires heavy cognitive load to maintain.
I think that's a great way to put it. At a sample size of 5, you are essentially just mapping your immediate sensory terrain.
But reaching a sample size of 10 represents a critical threshold in statistical analysis?
The resolution changes entirely.
It does. When you reach 10 people, you significantly upgrade the resolution of your data. Think of it like switching from standard definition television to 4K.
A resolution upgrade that allows for actual failure analysis. Because in the pure secretary problem, a rejected candidate is just a discarded variable, right?
Exactly.
But in a 4K resolution sample size of 10, those past relationships become vital, complex data points.
Which raises an important question. What do you actually do with that high-resolution data?
Right.
The source argues that a sample size of 10 gives you enough historical material to conduct systemic failure analysis. You stop looking at just the positive traits you enjoyed.
And you start analyzing the structural reasons why the relationships terminated. The examples the source provides for this are so specific and structural. It talks about a scenario where you compile the data from your relationships and realize a clear pattern.
Like finding out you consistently had incredibly fun, high-energy experiences with a specific type of person.
Yeah, but your underlying financial philosophies were so incompatible that it destroyed the foundation.
Or, you had a relationship where the external conditions were perfect, great on paper, aligned social circles.
But the data shows a systemic lack of psychological safety. Like you couldn't speak honestly during a conflict.
Right, and you simply cannot identify those overlapping complex patterns with an N of 2 or 3.
The realization here completely changes the entire objective of the dating phase. Increasing your sample size in the beginning isn't actually about rolling the dice more times to find an objectively superior human.
No, it's not. It's about calibrating your own internal algorithm.
You're discovering the delta between what you thought you wanted and what actually functions in reality.
Yes. You might program your initial search parameters to look for a fiercely independent, highly ambitious partner.
But by data point number 8, your failure analysis reveals that this specific variable consistently leaves you feeling isolated.
Exactly. And you realize what actually stabilizes your system is a partner who prioritizes quiet, shared time.
That calibration is essential. But the human brain's desire for data collection leads us straight into a massive statistical trap.
Oh, absolutely.
Because we see the benefit of upgrading our sample size from 5 to 10, our intuition scales that logic linearly.
We assume that a massive sample size, say dating 1,000 people, would give us a flawless, perfectly mapped statistical model of all potential partners on Earth.
Here's where it gets really interesting. Because the text takes that intuitive assumption and absolutely dismantles it.
It really tears it apart.
Let's look at the mathematical premise. The law of large numbers dictates that as your sample size grows, the results will converge on the actual average of the whole population.
Right, that's the standard statistical rule.
So, logically, if someone dates the 1,000 people, haven't they essentially run a perfect simulation of humanity? Haven't they sampled the 7 billion people on the planet?
What's fascinating here is why that is a complete misapplication of statistics. The source outlines two major reasons why dating 1,000 people does not create a miniature model of humanity.
Okay, what's the first one?
The first issue is variable continuity. Human traits are not fixed, mutually exclusive, discrete categories.
Right, it's not a hardware bin where you have exactly 16 distinct personality types and you just pull one of each to test them out.
Exactly. The variables, humor, trauma, values, physical appearance, economic background, they all bleed into each other in infinite continuous variations.
You can't mathematically isolate them.
No, you can't. And the second reason destroys the premise entirely. Your sample is inherently heavily biased.
How so?
Well, to apply the law of large numbers, your selection must be truly random. But your dating pool is skewed by your geographic coordinates, your socioeconomic bracket, your educational background.
Daily routines.
Right. And if you are using modern tools, it's skewed by highly engineered proprietary matching algorithms.
So an N of 1,000 is not humanity shrunk down. It is a heavily biased, localized cluster.
Exactly. Expanding the raw volume of your search doesn't solve the problem, it just exhausts your resources.
And this brings us to one of the most brutal mathematical realities in the entire text, the compound probability problem.
This is where the math gets really sobering.
The text explains that if you isolate a single trait, say a specific income bracket that exists in 10% of the population, your odds of finding it are straightforward. You just need a large enough sample to hit that 10%.
But human beings do not search for single traits. We search for combinations.
Right.
And in probability theory, when you require multiple independent conditions to be met simultaneously, you do not add their probabilities together. You must multiply them.
And multiplying fractions creates an exponential collapse.
Yeah.
Let's actually run the math on this because it is staggering.
Go for it.
Let's say you want a partner with a specific physical height or appearance that represents 10% of your dating pool.
Okay, 0.12.
Then you want them to have an income level that represents another 10%. If you want both simultaneously, you multiply 0.1 by 0.10. Your pool is now 1%.
It shrinks violently.
Now add a third variable. Say you need them to share your specific political or religious values, which might be 20% of your area. You multiply 0.01 by 0.20. Your pool is now 0.2%.
And it just keeps dropping.
Add in mutual attraction, add in being single, add in wanting children. You are rapidly multiplying fractions of a percent.
This is the fatal flaw in the endless searching model. Every single non-negotiable condition you stack onto your algorithm exponentially shrinks the available pool.
The required sample size balloons.
It balloons from a few dozen into impossible astronomical numbers. You would need to date tens of thousands, perhaps hundreds of thousands of people.
Wow.
The math literally proves that holding out for a flawless checklist is a statistical impossibility.
Okay, if we know that stacking ideal conditions drives the probability to near zero, how do we correctly evaluate the mathematical probability of the people who actually do pass our baseline filters?
Well, the source approaches this by recalibrating how we interpret statistical percentiles. Because human beings have a terrible tendency to misunderstand what percentiles actually measure.
The text provides the exact mathematical calculation for this, doesn't it?
It does. It states that in a random distribution, the expected percentile of the best candidate out of a sample size of n is calculated as n divided by n plus 1.
Okay, so if you date 5 people, the mathematically expected rank of the best person in that group is 5 over 6, meaning they are in the top 1/6 of the population, or the top 16.7%.
Right. And if you increase your sample size to 10 people, the formula is 10 over 11. The best person in that group is in the top 9.1%.
And the best out of 15 people puts them in the top 6.3%.
The math itself is sound, but this raises an important question about how we interpret those numbers. The text issues a very strong warning against a common cognitive fallacy here.
What's fallacy?
When a person hears that their partner is in the top 6.3%, their brain automatically converts that percentile ranking into an academic grading scale. They assume the person is a 93.7 out of 100.
Oh, I see. It's like bringing home an A- on a math test. Like,
Yeah.
I dated 15 people, I did the work, so I have mathematically earned an A- partner who will provide an A- level of happiness.
Exactly, which is a complete misinterpretation of the data. Human compatibility lacks an objective 100-point metric scale.
Right.
A statistical percentile of 16.7% does not inherently contain an 83.3-point value of kindness, loyalty, or relational joy. All that calculation tells you is the relative rank of that candidate compared to the overall group as your sample size expands.
It is a measurement of position, not a measurement of guaranteed output or happiness.
Precisely.
So what does this all mean? We can't rely on massive sample sizes to simulate humanity.
Yeah.
We mathematically cannot stack a dozen perfect conditions without shrinking our pool to zero.
Right.
And we can't use statistical percentiles as a grading rubric for our future happiness.
Uh,
How do you, the listener, actually use this data to finalize your stopping criteria?
that's the core issue.
How do you escape the agonizing loop of wondering if a statistically superior option is waiting just around the corner?
To escape the paralysis, the text argues that we must fundamentally shift our optimization metric. We have to stop optimizing for finding a perfect score, which we've just proven is statistically impossible,
And start optimizing for what?
for finding a sustainable foundation. But the crucial first step is algorithmic hygiene. You must design your stopping criteria at the correct time.
The text highlights the intense psychological danger of programming your criteria when your system is corrupted by fatigue.
Yes.
If you try to define your non-negotiables immediately after a string of brutal rejections or a painful failure, your data is completely skewed. You will pendulum swing wildly.
You absolutely will. You either drop your standards to the floor thinking you just need someone who is minimally polite.
Or you swing to the opposite extreme thinking, I've suffered so much, I am holding out for absolute mathematical perfection.
Exactly. You have to design your parameters when your system is energetic and objective.
And when you achieve that objective state, the source provides a very practical, three-tiered filter system to structure your algorithm.
Right. Tier 1 contains your absolutely non-negotiable conditions. These are the structural load-bearing pillars of a partnership.
Safety, respect, things like that.
Yes. Tier 2 contains conditions you would ideally like to have. Preferences that optimize the system, but their absence won't cause structural collapse.
And Tier 3 contains bonus conditions. It's nice if they share your highly obscure weekend hobby, but the relationship survives perfectly well without it. The failure mode for most people is that they take a Tier 2 preference, like a specific career trajectory or a shared social aesthetic, and they hard-code it into Tier 1 as a non-negotiable.
Which, as we know from the compound probability math, instantly destroys their chances of success.
It totally does. But what I love most about this text is the profound pivot it makes regarding the ultimate goal of dating.
It's a huge perspective shift.
Instead of treating the search like an arcade game, where you were constantly trying to break your past high score of how intensely infatuated you were with someone,
Right.
you should be analyzing your data to answer one highly specific question. Is this the easiest relationship to build?
If we connect this to the bigger picture, it requires accepting that marriage, or any lifelong partnership, is not the acquisition of a finished static asset.
You aren't buying a product off a shelf that maintains a fixed value.
Exactly. A relationship is an ongoing dynamic adjustment between two inherently imperfect variables.
Two dynamic, imperfect variables operating in an unpredictable environment.
Precisely. If that Tier 1 foundation is mathematically sound, meaning you have established psychological safety, mutual respect, and a mechanism for resolving conflict without destroying the system,
Then what?
then accepting a partner who has different Tier 3 hobbies or differing external conditions is not compromising. It isn't settling.
It's making a highly calculated, rational choice to invest in building reality, rather than exhausting your resources chasing a statistical ghost.
Yes. You are optimizing for long-term stability and growth, rather than optimizing for an arbitrary, statistically flawed initial high score.
Okay, to bring all of this incredible mathematical analysis together for you, the listener, what we've discovered today is that the 37% rule and the mechanics of probability aren't meant to turn your romantic life into a cold, unfeeling spreadsheet.
Quite the opposite, really.
Right. They provide you with the mathematical permission to stop looking for a mythical 100-point unicorn. Your past relationships, those 5, 10, or 15 people you observed, they weren't failures.
No, they were the essential, hard-earned data points you needed to upgrade your resolution and refine your search parameters.
You mathematically needed them to understand the delta between what you thought you wanted and what actually stabilizes your life.
And the final takeaway from the mathematics of optimal stopping is deeply empowering. Once your observation phase has provided enough data to understand your true structural non-negotiables, and you identify a partner whose foundation aligns with those Tier 1 criteria, stopping the search is not giving up.
It's the goal.
Halting the data collection to focus entirely on building that foundation is mathematically, logically, and emotionally the absolute optimal move.
I want to leave you with one final, slightly provocative thought to mull over. We spent this entire deep dive looking at how to measure and evaluate the data of other people.
Right.
We've looked at their percentiles, their traits, their variables. But remember, throughout this entire complex equation, the evaluator, which is you, is not a static measuring stick.
That's a fascinating point.
As you observe those initial data points, as you experience those failures and successes, your own emotional capacity, your own values, and your own definitions of the ideal are constantly mutating.
You are a dynamic variable inside your own algorithm.
Exactly. So perhaps the ultimate optimal starting point isn't just about finding the perfectly aligned data point in someone else. Maybe the true mathematical peak is recognizing the exact moment your own internal algorithm finally stops changing, stops constantly calculating, and simply settles into place.